Have you ever tried writing recursive functions? Did you know tail recursion is completely different from normal recursion? Same output, totally different efficiency. Let's break it down and see who wins the stack game. In normal recursion, each call waits for the next one to finish. That means the work is pending on the stack. This is the classic factorial function where each call multiplies its result after the recursive call returns. When factorial 5 is called, the first call goes in, then factorial 4, 3, 2 and 1 follow one after the other. Each call stacks neatly on top of the previous one, 5, 4, 3, 2 and then 1 until the stack looks like a tall tower of waiting functions. At this point, none of them can complete until the deepest one, that is factorial 1, finishes first. You can literally see the stack growing higher with every call. And if you keep going with larger numbers, let's say factorial 10,000, that tower gets so tall that it crashes and leads to a Stack Overflow error. Once the final call returns, the stack starts collapsing from the top, sending the results back step by step, just like the LIFO rule that we follow in the stack. So what if we could write recursion that doesn't stack up? That's where tail recursion comes in. In tail recursion, the recursive call is the last step, nothing left to do after it returns. That's why the stack stays flat and there is no pending work. Here you can see a tail recursive factorial function. Each call passes the running result forward as the product. You can also use accumulator variable here because that's the basic concept. No multiplication happens after the return statement because it is already done. In tail recursion, every call replaces the previous one. At any moment, only one function call stays in the stack. That's why it stays flat. And with tail call optimization, compilers can reuse the same memory frame. But remember, not all compilers perform TCO automatically. If the optimization is not enabled, even the tail recursion can still build up the stack. So here is where TCO works and where it doesn't. Tail recursion is more memory efficient while normal recursion is often easier to read. Both give the same results, but tail recursion wins the efficiency game. If you enjoyed this explainer, subscribe for more computer science insights and tell me in the comments, do you prefer recursion or iteration?